Hello and welcome to the EMC Live webinar, 2.4 gigahertz wireless designs to Europe, big changes to EN 300 through 28 next year. My name is Belinda Stashukevich and I'm the editor of Interference Technology, the creator of EMC Live. EMC Live is a brand new online 3-day event hosted by Interference Technology, featuring practical information and topics. This event will include roundtables, webinars, and videos on everything EMC related. Please visit our site to check out the other webinars we've had this week. This webinar is presented by Sam Wismer, VP of Technology, and Kirby Munroe, Director of Wireless Certification at Advanced Compliance Solutions. This webinar is sponsored by Advanced Compliance Solutions. ACS's innovation ensures those products can reach the market quickly and efficiently, maximizing revenue and opportunity. They design their industry-leading facilities to adapt to the complex needs of customers, meet the demands of global compliance, and provide optimal service throughout the process. This webinar is one of many. To check out our others, visit emclive2014.com. A recording of this webinar and downloadable PDFs will be available on our website shortly. This webinar will be interactive. You'll be able to ask questions, and we encourage you to participate. Take a look at your GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or report an issue, click the hand icon. We'll present the topic for 35 minutes, followed by a 10-minute question and answer session. Now Sam and Kirby will begin the presentation.
Good afternoon. Thank you, Belinda. This is Sam Wismer. I want to first thank you all for participating in this presentation. As I mentioned, I am the VP of Technologies at Advanced Compliance Solutions. We've been very busy gearing up and educating our clients for the transition to version 1.8.1 of ETSI EN 300-328. We've been involved in this for over a year now, and with the 12/31/2014 deadline for transition to version 1.8.1 fast approaching, there's mounting interest in what the changes mean for manufacturers, integrators, and test labs. The changes from 1.7.1 to 1.8.1 are very significant, numerous, and very complex. Our presentation this afternoon will provide as much detail as possible in the time allowed. Kirby Munroe is our Director of Wireless Certifications, and he has been in the trenches developing test capability for ACS, as well as being in the forefront in educating our customers. He will be delivering the technical content of this presentation. Before we get to that, though, I'd like to kind of go through the outline of the presentation with you so you can kind of get an idea of what the topics are that we're going to discuss today. So we'll briefly discuss the structure of the R&TTE Directive, which include the essential requirements and harmonized standards, and how ETSI EN 300-328 fits into the directive. The R&TTE Directive is another topic altogether, but it is important to understand how it is structured at a high level relative to this presentation. Obviously, we'll also discuss in detail EN 300-328 to include its history, the changes coming in V.1.8.1, challenges of the new standard for both the manufacturer and for the test lab, and then we'll also discuss how to prepare for the lab visit, and then finally what's coming beyond version 1.8.1. There's a lot to these European directives, but we'll discuss briefly the requirements that have to be met and how they have to be met. As with most all of the European directives, the R&TTE Directive has a minimum set of essential requirements that must be met for equipment to be marketed in the European Union. When equipment has demonstrated compliance with these essential requirements, they can then be freely marketed anywhere in the European Union. That is, unless any of the member states has any published restrictions on the operation of certain equipment, and this could include the use of harmonized frequency bands as an example, or non-harmonized frequency bands, I should say. The essential requirements are described in qualitative terms, which are the protection of health and safety of the user and any other person based on the protective requirements of the Low Voltage Directive. Also, it includes requirements for compliance to the Electromagnetic Compatibility Directive. And then finally, the effective use of the radio spectrum orbital resource so as to avoid harmful interference. In basic terms, the first two essential requirements require compliance with the LVD and the EMCD respectively. Notwithstanding those, it is the last essential requirement that we'll be discussing how to satisfy today by testing products to EN 300-328 or any other radio frequency spectrum product standard that may apply. So moving on to harmonized standards, in order to meet these essential requirements, the R&TTE Directive relies on harmonized standards developed by recognized European standards organizations. In these harmonized standards, they define the technical characteristics needed to comply with the essential requirements. ETSI 300-328 is a harmonized European standard under the R&TTE Directive. So that's the brief overview of the R&TTE Directive, and that effectively concludes my part of the presentation. At this point, I know everybody's here to hear about the technical content, so I'd like to turn the presentation over to Kirby Munroe to provide the technical details of the rest of the presentation.
Thanks, Sam. I'd also like to welcome everyone, and I hope the information provided in this presentation answers some of the questions you might have, or at least provides a better insight into 300-328 standard. As Sam just mentioned, ETSI EN 300-328 is a harmonized standard, and it does satisfy one of the three essential requirements that were shown previously. It specifically satisfies the one essential requirement for the effective use of the radio spectrum. And unlike some of the other generic standards like EN 300-220, which is generic for a variety of short-range devices, 300-328 is radio specific. This means that it applies to specific radio type or technology, which in this case is data transmission equipment operating in the 2.4 gig band using wideband modulation techniques. 300-328 covers technologies like Wi-Fi, Bluetooth, and Zigbee, but it also covers other equipment that uses the 2.4 gig band, which would include proprietary wideband and frequency hopping devices. Now let's discuss a brief history of 300-328. The initial 300-328 standard was first published in 1994, but we're going to start at version 1.6.1 just to show some of the progression over the last few years. 1.6.1 was issued in 2004 and was very basic with respect to the technical requirements needed for compliance. It didn't include requirements for spectrum sharing, and it relied on simple measurement techniques for showing compliance with some of the other technical parameters. In 2006, ETSI released version 1.7.1. This standard had improved, although still simple, measurement methods for the existing technical requirements. It also included additional requirements for frequency hopping equipment that we hadn't seen in some of the previous versions. In addition to the frequency hopping requirements, version 1.7.1 also included the requirement for medium access protocol. Medium access protocol is defined as a mechanism that's designed to facilitate spectrum sharing with other devices in a wireless network. Spectrum sharing hadn't been an issue in the past, mainly due to the ability of similar technologies like Wi-Fi and Bluetooth to mitigate sharing. But as some newer technologies were introduced, spectrum sharing and providing equal access became more of a concern. So with that, the requirement for medium access protocol was added. It didn't take long to see that there were some issues and limitations with version 1.7.1. It didn't provide test procedures for the new frequency hopping and medium access protocol requirements. And although these had to be complied with as a necessary condition for presumption of conformity, conformance could be claimed by an equivalent test or simply by a manufacturer's declaration. This wasn't so much an issue for the frequency hopping requirements because in most cases those could easily be declared by the manufacturer based on the equipment technology. So if you take Bluetooth, for example, the hopping characteristics are defined in the Bluetooth standard. So in this case, the declaration would be simple. But medium access protocol wasn't as trivial. Some manufacturers simply didn't understand what was necessary to meet this requirement, and others just assumed it would be addressed in the device protocol. Even after several notes were included in the official journal over the last few years that indicated compliance was mandatory, for the most part it was still being ignored. With version 1.7.1 deemed insufficient to guarantee presumption of conformity for spectrum sharing and the need for the new, better defined, and more precise test methods and requirements, version 1.8.1 was released. It was published in June of 2012, and was a complete overhaul from its predecessor. It has well-defined spectrum sharing and spectrum usage requirements, as well as test methods for several different technologies and spectrum sharing techniques. The previously undefined test procedures for frequency hopping equipment were also included, as well as drastically revised and more complex test procedures for some of the existing requirements, such as RF output power and power density. In the following slides, I'll discuss each of the 1.8.1 technical requirements, and I'll outline some of the key differences from version 1.7.1. There are a total of 12 technical requirements, but not all may apply to the equipment under test. Certain requirements apply to all equipment, while others apply to specific modulation types or equipment characteristics. Some are specific to frequency hoppers, while others for non-frequency hoppers. Output power and whether or not your device is adaptive also determines which apply and which don't. RF output power applies to both frequency hopping and non-frequency hopping equipment. Although the limit remains the same, this is a much more complex test procedure when compared to version 1.7.1. It's no longer just a simple power meter measurement. The test method requires a power meter with a sampling speed of at least 1 megasample per second, and it requires significant data processing for the final result. It's the raw data from each sample that needs to be stored and mathematically processed to determine the RF output power. For devices with multiple antenna chains, you have to synchronize the measurements so the power sensors are triggered to start sampling at the same time. So for a MIMO device with 4 antenna chains, you're talking 4 million samples per second that are collected and processed. The duty cycle, TX sequence, and TX gap requirements are new, and they were designed to help ensure efficient use of the spectrum. Duty cycle is the ratio of the total transmitter on time over a specified period. And the TX sequence and TX gap requirements provide a closer look at the individual transmission bursts. If 2 transmission bursts are separated by less than the manufacturer's declared TX gap value, the duration of those 2 bursts is considered a TX sequence. 1.8.1 provides a limit on the duration of the maximum TX sequence and the minimum TX gap, and it's different for frequency hopping and non-frequency hopping equipment. These requirements do not apply to equipment with EIRP less than 10 milliwatts or to equipment that operates in a non-adaptive mode. These tests also require data processing for the final result. The sample values from the RF output power test are used to construct individual transmissions so that the duty cycle, TX sequences, and TX gaps can be measured. Power spectral density is an existing requirement from version 1.7.1, but the test method has changed and it's also more complex. It's no longer just a simple spectrum analyzer measurement where the spectral plot is used to show compliance. As with version 1.7.1, it only applies to non-frequency hopping equipment, and the limit is still 10 milliwatts per megahertz EIRP. As with the RF output power test, power density also requires some data processing. The spectrum analyzer trace data is stored, the individual bins are normalized and then summed over 1 megahertz segments for the final result. As we previously mentioned, the test methods for evaluating frequency hopping characteristics is new, and the limits are better defined. No longer can you simply declare compliance as you did with 1.7.1. You must follow the prescribed test methods. The specific technical requirements include dwell time, minimum frequency occupation, hopping sequence, and hopping frequency separation. Again, the analyzer trace data is used, but only for the dwell time and the minimum frequency occupation tests. Compliance with the hopping sequence and the hopping frequency separation, that's determined directly from a spectral plot. The medium utilization factor requirement is a measurement to quantify the amount of resources in power and time for non-adaptive equipment. The goal here is to help ensure equal access to the spectrum. And although the methods weren't previously defined in 1.7.1, this test procedure was developed to show compliance to the medium access protocol requirements. This is not applicable to equipment with EIRP less than 10 milliwatts, and it includes the duty cycle measurement in combination with the RF output power to determine compliance. It's basically calculated as the ratio of the measured power to the power limit of 100 milliwatts multiplied by the duty cycle. The limit for both hopping and non-hopping equipment is 10%, which means that if a device is operating at the maximum 100 milliwatt output power, the duty cycle has to be limited to 10% for compliance. Adaptivity is a mechanism where equipment can adapt to its environment by identifying other transmissions present in the band. Once again, the goal of this test is to help ensure spectrum sharing, and it was also developed to show compliance to the Medium Access Protocol requirements of version 1.7.1. Adaptivity only applies to equipment with EIRP greater than or equal to 10 milliwatts, and it covers frequency hopping and non-frequency hopping equipment using both listen before talk and non-LVT based technologies. The test procedure differentiates between adaptive frequency hopping using detect and avoid mechanisms and adaptive equipment using modulations other than frequency hopping spread spectrum. The test includes injecting a band-limited noise interference signal as well as a CW blocking signal into the EUT. You determine compliance by monitoring the carrier reaction. It covers both the adaptivity and the receiver blocking technical requirements of 1.8.1. The occupied channel bandwidth technical requirement includes a 99% occupied bandwidth measurement, with the results used to determine if the emission is contained within the 2.4 gig band. The requirement for transmitter unwanted emissions in the out-of-band domain uses an emission mask as the limit. Both of these replace the frequency range requirement of 1.7.1, but it also includes a revised, more complex test procedure. It's no longer just a simple spectral plot, but it's two distinct measurement methods. The method for the emissions in the out-of-band domain uses the occupied channel bandwidth results for determining compliance with the mask. Transmitter unwanted emissions in the spurious domain and the receiver spurious emission requirements were both included in version 1.7.1, but both the test procedures and the limits have changed. The test procedures are now aligned with other harmonized standards and include changes to the measurement settings like resolution bandwidth, video bandwidth, and the detector type. The limits and methods in version 1.8.1 also distinguish between narrowband and wideband emissions, as 1.7.1 did. This means that the additional test and limits for wideband emissions no longer apply. The limit for transmitter spurious emissions is also new, and it now includes several bands below 1 gig with more stringent requirements. There are other changes not related to the test procedures or limits, but the use of test modes is probably the one that's getting the most attention. Version 1.8.1 does not allow for the use of traditional test modes. Some of us may be familiar with the test modes that force a continuous transmitted signal at 100% duty cycle. To show compliance with most radio standards, this is typically how devices are configured. Well, that's no longer allowed, and 1.8.1 states that measurements be performed using normal operation of the equipment, specifically with the equipment operating in a worst-case modulation scheme. Test requirements like duty cycle and RF output power require the use of these realistic modes to show a true picture of how the device works under normal conditions. This is something that traditional modes typically don't offer, and in fact there can be instances where test modes behave differently from when a device is configured for normal operation, and yet this is another reason for the no test mode requirement. But achieving a worst-case normal mode might not be that simple to accomplish. You still may need some special firmware to force specific characteristics such as bandwidth, data rate, or packet types. Yet another reason for using normal modes is that the market surveillance authorities can perform testing without asking for the manufacturer for special tools or software. With the new and revised test procedures, the new test requirements, and a host of other changes, it's kind of easy to see why the transition from 1.7.1 to 1.8.1 is causing such a stir with the manufacturers, the integrators, and the test labs. Right now, manufacturers can either apply version 1.7.1 or 1.8.1 to comply with the essential requirements of the directive. However, as it was noted in the official journal in October of 2012, compliance with the Medium Access Protocol requirements in 1.7.1 is mandatory, and it's recommended that the test procedures defined in 1.8.1 be used. So whether you apply 1.7.1 or 1.8.1, you can't escape the need for spectrum sharing. But as of January 1st, 2015, 1.7.1 will no longer provide a presumption of conformity, and 1.8.1 will be the sole harmonized standard. In short, after January 1st, 2015, any product imported or marketed for sale has to comply with 1.8.1. Now let's discuss some of the challenges of version 1.8.1. Because this standard is distinctly different from the previous versions, it's important for manufacturers to understand some of the challenges they face. It's the manufacturer's responsibility to ensure their products are capable of complying with technical requirements and that they can be properly configured for testing. To achieve this, it's imperative that manufacturers become extremely familiar with every aspect of the standard. To ensure their design is capable of compliance, manufacturers must source the correct components. For example, before deciding on a specific chipset for the design, it's important to understand if it's capable of meeting the requirements. You might be interested in knowing if it has adaptive modes or if the firmware is designed to ensure compliance with the medium utilization or the hopping requirements. It's also imperative that manufacturers understand how to configure the equipment for testing. Considering that test modes are no longer allowed, manufacturers need to provide instructions and accessory equipment for operating under worst-case scenarios. The device has to be capable of operating in a mode that produces maximum throughput or in a mode that might not normally exist when using test modes. It's not only the manufacturers that face challenges in preparing for 1.8.1, the test labs also face some issues. Being a complete departure for 1.7.1, the test labs are forced to acquire or develop specialized test systems which are capable of collecting, processing, and analyzing the data for several of the new test procedures. These tests go beyond what is commonly used for compliance today, and as we've learned, they require the ability for complex data processing. Not only do test labs need to implement specialized test systems, but they also need to be intimately familiar with every aspect of the standard and the technology in which the standard supports. This requires test labs to understand all capabilities of wireless technologies, such as Wi-Fi, Bluetooth, and Zigbee. There may be cases where even the manufacturers don't fully understand what the equipment's capabilities are, and in turn they rely on the test labs for support and knowledge. So without understanding the technology and how it relates to the standard, test labs can struggle with identifying and applying the correct requirements. Being prepared for your lab visit will ensure a smooth and trouble-free experience. As I previously mentioned, the device under test should be capable of producing all available modes, modulations, and data rates without the use of any of the traditional test modes. For example, 802.11, all data rates and bandwidth should be accessible. For Bluetooth, all modes and packet types are needed. This includes classic Bluetooth, EDR, adaptive frequency hopping, and the low energy modes if available. Some of these modes are sometimes not typically available to the user, so it might require a unique configuration or special firmware to achieve. It may be necessary to place your device in a network configuration with a companion product, or you may need specialized communications equipment to exercise all the modes. Documentation is also needed by the test labs, and it should be provided prior to your visit. It's this information that helps the lab understand the full functionality of the product. And in addition, the information supplied is often required as input variables to the individual test suites. The 1.8.1 standard does include a checklist in Annex F, and it has the necessary information for the lab. This checklist is required to be included in the test report, so it's essential that it's complete and it's accurate. Any incorrect information included in this checklist could impact the test results. Equipment submitted for test should be supplied with the cables, connectors, and accessory equipment necessary for testing. Supplying a device to a test lab without a way to access the RF output port or a way to provide power would certainly be an issue. Also keep in mind that some tests must be performed under extreme voltages, so it's important to provide a means to vary the input voltage as well. You shouldn't expect the test lab to have all the accessories or to make any modifications to your product. So not understanding how the equipment should be configured or not supplying the necessary documentation and hardware can create delays in testing and can produce non-representative and even non-compliant results. So it's very important to have everything in order before your lab visit. What's coming with EN 300-328 and beyond version 1.8.1? Well, that would be version 1.8.2. The draft version of 1.8.2 was released in April of this year, and the final harmonized standard is expected to be published next year as version 1.9.1. There are several changes included in 1.8.2 that should reduce some of the misunderstandings and confusion that we've seen in 1.8.1. The overall scope and the essential requirements of the standard remain the same, However, there are changes that include new and revised definitions, modifications to the limits, and simplification and clarification of test methods. For frequency hopping equipment, the definition for dwell time was clarified. And based on this clarification, the conformance requirement for dwell time was renamed to accumulated transmit time. Apparently, there was some confusion regarding the definition and the limit, mainly because version 1.8.1 makes it seem like the limit is applied to the accumulated channel dwell time and not the accumulated channel transmit time. Also for frequency hoppers, the requirement for minimum frequency occupation was renamed to just frequency occupation, and it now includes two options for compliance, one being an occupation probability. With that, conformance with both accumulated transmit time and frequency occupation can now be made using statistical analysis by the manufacturer. This only applies to certain circumstances, however. An example of this is when you cannot measure your idle or your receive periods during the hop sequence. The adaptivity conformance requirement for non-frequency hopping devices using Listen Before Talk was also modified to remove the random variable R and the value Q. These variables are used for calculating the extended clear channel assessment time and the channel occupancy time. And they're a little confusing, so instead of using R and Q, the clear channel assessment time and the channel occupancy time are now fixed values or a range of fixed values to simplify the test methods. The transmitter unwanted emissions in the spurious domain and the receiver spurious emission requirements have also changed in version 1.8.2. 1.8.2 includes a clarification on the requirement for both conducted and radiated measurements. Version 1.7.1, as well as other harmonized standards, include a requirement that spurious emissions either be measured at the antenna port and from the equipment cabinet or from the equipment with the antenna attached. But for some reason, this wasn't included in 1.8.1, but was added back for the new version. The test procedures for spurious emissions were also modified and slightly better defined. They've made changes to the number of sweep points, and the standard also defines the spectrum analyzer filter as a 3 dB filter. The test procedure now requires a zero-span video-triggered measurement for the time domain power for each spurious emission, where previously this was just a simple narrowband measurement. There are other changes in 1.8.2, but they're just too numerous to detail. But all of these changes were put into place to help clarify some of the conformance requirements and test methods and hopefully eliminate some of the questions and confusion already seen in 1.8.1. Well, EN 300-328 version 1.10.1 is already on the horizon. And in fact, I believe a task group has already been commissioned to begin work on this standard. We don't know much about the expected content of 1.10.1, but it's assumed that it will provide even more clarification and possibly even new test methods. So I guess you can now see why 300-328 is such a hot topic. With all the changes from revision to revision and the speed at which it's progressing, there was bound to be some confusion. So I hope the presentation we gave today was helpful.
Great, thank you so much. We'd like to have a call for final questions. Please enter any last questions you may have in the navigation pane. Here's a question for you. Will existing tests based on the version 1.7 be allowed to be exported to EU nations, or would it require to be complied to the new directives as under 1.8.1?
Okay, the answer to that question is that it has to comply with the new revision of 1.8.1. You know, I often get asked this question, particularly if the radiated emissions data could be used to show compliance with 1.8.1. But the answer is no. All essential requirements have changed in one facet or another. And for radiated emissions, because of the changes in the test procedures and the limits, which are much more stringent, testing has to be repeated. And that really is across the board for all the essential requirements.
Great. Can you outline the test equipment required for tests? Is there a cost-effective solution?
This is Sam. I'll try to address that. There's two ways to go about it. You can build your own test systems if you are intimately familiar with the types of measurements that have to be made, or there are now some turnkey systems that are being generated But as far as being cost effective, I think given that this is all brand new to the market, that it'll be hard to find a cost effective solution that relative to typical test equipment. It's a very complicated test equipment and requires a lot of analysis that has to be done, a lot of automation. So I don't think that there's anything that's real cost effective yet out there on the market.
Great. If we used a certified module but we change the antenna, what are the tests that need to be done?
Well, if the module was tested under the new version of 1.8.1, there are quite a few tests that need to be redone. It really depends on the change in the antenna, because most of the tests in 1.8.1, such as the power density, those are related to effective radiated power, effective isotropic radiated power. So any change in the antenna gain would affect the outcome of those tests. Also, the change in the antenna would affect the radiated emissions. So there's a potential that you would have to repeat a majority of the tests under 1.8.1. If it was an existing or tested under the previous standard or the current standard 1.7.1, you would essentially need to retest the entire module for all essential requirements under version 1.8.1.
We had another question. So are you saying all existing approved products have to be retested?
Well, as of January 1st, any product that is being marketed or offered for sale must meet the requirements of version 1.8.1.
Yeah, 1.7.1 becomes obsolete at that point, and everything that's continued to be offered for sale has to meet the new requirements.
We have another question. There's been a lot of talk of 328 and the 2.4 gigahertz range. I assume that the 693 spec for the 5 gigahertz devices are following suit.
It's EN301893 is the 5 gigahertz standard. At least that's the one I understand. That standard has had the unique test procedures, the DFS requirements, the adaptivity. I mean, there has been, it's not as drastic as a change. So essentially, if it's met that standard, the previous version of that standard before, you shouldn't have too much issues getting the new revision.
So that standard is relatively new to the market anyway, within the last 7-8 years, and it's a more mature standard when it was developed in the first place, whereas 300-328 was started as a very basic standard and is only now reaching its maturity.
Here's another question. How does the change from 1.7.1 to 1.8.1 impact quoted test time and cost? What type of multiplier?
That's a hard one. It depends on the type of equipment. There's various levels of complexity in the types of radios that fall into the scope of this standard. There's a simple classic Bluetooth to the all the way to the 802.11 N radios that may have multiple antenna chains. So it's very difficult to say. However, the more complex you get, that multiplier certainly increases. And I'm not sure how to really quantify that.
No, I don't think you can quantify it as a multiplier. I mean, there is a difference in, obviously, the complexity of the tests. Depending on the type of test system the test lab may have, it may not equate to much more additional time in the testing effort. But because of the complexity of the test, you definitely or typically see a cost increase going from 1.7.1 to 1.8.1.
Great. Another question. If there's an RF module tested as compliant to 1.8.1, does that mean final equipment tested under 1.7.1 has to be retested for the unintended radiation in sub 1 gigahertz?
If the module has been tested to 1.8.1, that module should, there are some limitations on integrating that into host devices. There may be additional tests required for integrating that into specific hosts. But I'm not sure what is meant by the host device complying to 1.7.1.
The requirements for the host device would be the EMC requirements under the EMC Directive, and not the radio spectrum standard. The radio spectrum standard would apply to the radio module itself, but for as far as an improved module being integrated into a host device, you are introducing another potential source for unintended emissions, and those do have to be evaluated. I'm not sure we answered the question as it was intended, but that's how we heard it.
Okay. Another question. As a test lab, what specifically would one need to start looking at for equipment upgrades from standard test receivers?
Test receivers.
So the question is, what additional equipment would a test lab need to get over and above what they have generally used to test to previous versions of version 1.8.1? Is that correct?
Yes.
Okay. You want to?
Yeah. The test receivers are actually spectrum analyzer in this case. There are requirements for minimum number of sweep points, 99% bandwidth functions within the analyzer. Other equipment would include spectrum or signal generators, vector signal generators for some of the adaptivity testing. Power meters, you'd also need the software capabilities to collect and process the data as well.
Yeah, that's one thing to understand is that generally in these types of measurements, you make a measurement and whatever displays on the screen you can compare to a limit and determine whether it passes or fails. In this case, in the case of the new standards, there's so much analysis that has to be done that that all takes place after the measurement is actually made. So the automation software is key.
Okay, we have another question. Can low-power devices operating under 10 meters per watts, such as Bluetooth and Zigbee, be certified under 220 for low-power devices instead of 328?
That's actually a pretty good question. You know, Bluetooth devices, the standard, the 300/328 standard specifically calls out Bluetooth as being specific to that standard. So, you know, that's really probably a notified body question as far as how they would handle it, and you may find that you get different opinions. But I have had experience where a notified body said if there is a radio-specific standard out there, which this is, then it must be applied.
Okay. What is the cost for retesting a system to comply with 1.8.1 versus the fine for only complying with 1.7.1 after January 1st, 2015?
Well, that's really product specific. Like Sam had mentioned earlier, you know, you have very simple devices, Zigbee, even like the classic Bluetooth, and then you have very complex devices. You know, a 4x4 MIMO device, 802.11 in AC. So there's drastic differences in the effort involved between those two products. So to put a cost figure on that is really impossible without knowing a little bit more detail on the product.
I'll take a quick stab at it. You know, for a very simple device, the classic Bluetooth, there may not be much of any increase at all. But as you get up into the more complex stuff, you could easily get to you know, 1.5 to 3 times the cost that the previous version was tested to.
Great. We have one more final question. I've heard that Wi-Fi can't meet the requirements of 1.8.1. Is it true, and what is it about Wi-Fi that causes this?
Well, if you've read through the IEEE standard, the 802.11 standard, you'll see that it includes mechanisms for medium access control or spectrum sharing. From what I understand, most chip manufacturers haven't implemented that function in the firmware. In order to meet conformance requirements of 1.8.1, non-adaptive equipment greater than 10 milliwatts EIRP must conform to the medium utilization requirements. But based on the high duty cycle of 802.11, the medium utilization requirement can't be met. So without adaptivity, the 802.11 devices must limit power to less than 10 milliwatts EIRP, and I think for most manufacturers that's unacceptable.
Thank you so much. We appreciate everybody's questions and time. Thank you, Sam and Kirby, for your expertise. If you have any more questions that we have not answered here, you can email us at info@emclive2014.com. We can pass your questions along. Please join us next year for EMC Live 2015, which takes place April 28th to 30th. Attendees, if you have any more questions, please send us an email. A recording of this webinar will be available on our website. We will also send a link to all participants shortly. Thank you for attending.